Alright, in this video we are going to solve a few trig equations such as these. Now at a glance I'm seeing that I have two different kinds of trig function. That's not okay. We need to somehow rearrange this to be one type. Now I have memorized that cosine squared plus 1, did I say cosine? I meant cotangent squared plus 1 is equal to cosecant squared. So this is an identity, one of the Pythagorean identities that you're supposed to memorize. So using this, let me get cotangent squared by itself. So I'm going to subtract 1 from both sides. So cotangent squared is equal to cosecant squared minus 1. So I could do this substitution. I could take cotangent squared and replace it with cosecant squared minus 1. So let's do that. So that'll give me 2 times cosecant squared x minus 1, like I said, and then minus 3 cosecant x is equal to 0. Now I'm going to erase this because I might need the space. So we'll have to do the distributive property here. So that'll be 2 cosecant squared x minus 2 minus 3 cosecant x is equal to 0. Just rearranging this in descending degree order. So I have 2 cosecant squared x. And then I'm going to write this term next, minus 3 cosecant x. And then I'll put the constant last like you do. Minus 2 equals 0. So I just switch these around basically. Now, this is probably factorable. So let's give that a try. So 2 cosecant squared, that could be factored as 2 cosecant times cosecant. Now 2 can be factored as 2 times 1 or 1 times 2. Now, I know not to put the 2 here because that would make a common factor, with the both 2's in the same set of parentheses. And there's no common factor in the previous step, so there shouldn't be a common factor inside the parentheses either. That's a shortcut. So I will go straight to 1 here and 2 here. Now I know that inner plus outer must equal the middle. So inner, I have 1 cosecant x. Outer, multiply, I have 4 cosecant x. Now I'm trying to get a middle of negative 3 cosecant x. So how can I get negative 3 cosecant x out of these two? Well, if this is positive and this was negative, that would make negative 3. So that means this has to be positive and this would need to be negative. Okay, also positive 1 times negative 2 does give me negative 2, so that works as well. Very important. So great, we factored it. So now I can continue by setting these factors equal to 0. So 2 cosecant x plus 1 is equal to 0. And cosecant x minus 2 is equal to 0. Excuse me. Subtracting 1 from both sides, so I have 2 cosecant x is equal to negative 1. And dividing both sides by 2, I guess I'll go ahead and show it. Dividing both sides by 2 gives me cosecant x equals negative 1/2. Alright, that's as far as I can go there before I can get my actual solutions. Meanwhile, over here, I'm just adding 2 to both sides. So that's going to give me cosecant x is equal to 2. Alright, let's wrap this up. Whoa, didn't mean to put a mark there. Skirt. So, cosecant. Well, remember that cosecant is the reciprocal of the sine function. Cosecant is the reciprocal of sine. So if I do the reciprocal of both sides of the equation, then the reciprocal of cosecant is the sine function. So if I do the reciprocal over here, then that will turn this into a sine function. Whoops, didn't mean to change to theta though. Okay, so there I just did the reciprocal of that side, and the reciprocal of this would be negative 2. Alright, because it would be negative 2 over 1, which is just negative 2. Now if I do the same thing over here, I'm going to do the reciprocal of both sides. The reciprocal of cosecant, again, is sine, and the reciprocal of this would be 1/2. Okay, so now it's a matter of what are the solutions here. Well, sine goes up to a positive 1 and down to a negative 1 if you're looking at the unit circle. So sine does not get you to negative 2. It doesn't go that low. So we're going to have a big empty set over here. There's no solution. There's no angle that's going to give you a negative 2. Now how about 1/2? This is one of those facts that you're supposed to memorize. The sine of pi over 6 is 1/2. All right, everything on this chart you're supposed to memorize. Okay, so that means that the reference angle is going to be pi over 6. Now that's a reference angle. That's not necessarily the answer. But as soon as I hear that the reference angle has to be pi over 6, then I'm going to draw a unit circle with a bunch of pi over 6's on it. So looking in the top half of the circle, I know the top semicircle is pi. So if I divide this up into 6 slices, then that'll be pi divided by 6, or pi over 6. So I'm just looking at the top half. Now here I have 3 sections, and so if I do that again right here, okay, that's a little bit crooked, but still 1, 2, 3, 4, 5, 6. I have 6 slices up there. That means each one of these is going to be pi over 6. Now, we're talking about reference angles though. So these are the 4 angles that will have a reference angle of pi over 6. So if I do the sine of any one of these 4 angles, then I'm going to get some kind of 1/2. But 2 of them will be positive, 2 of them will be negative. Remember that on a unit circle, every point is in the form x comma y. And it is the y coordinate that is the sine of the angle. So that means, you know, above the x-axis, y is positive. So that means that these are the 2 angles that will give me positive 1/2. Below the x-axis, a y value is negative. So that's why these are the 2 angles that will give me negative 1/2. So for this particular problem, hold on, let me just make some space. For this particular problem, we want positive 1/2. So we're going to be looking exclusively at these 2 angles for our solutions. So this is 1 pi over 6, okay, right off the bat. And then I've got 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So 5 pi over 6 is the other angle that will give me a positive 1/2. So x is equal to pi over 6 or 5 pi over 6. Okay, let's see if we can do 2 more. Let's see, so that was number 7, right? Make sure I'm not skipping anything. So let's move on to number 8. Well, at least this time, right from the beginning, we have all cosine. So maybe this problem will be easy. Let's go ahead and factor this. So let's see. 2 cosine squared would factor as 2 cosine times cosine. 1 can only factor as 1 times 1. Now, inner plus outer must equal the middle. This is the middle that I'm talking about. So inner, I have 1 cosine x. Outer, if I multiply these, I have 2 cosine x. Inner plus outer must equal middle. Well, if I want to get positive 3 cosine, I need both of these to stay positive. So that means both of these must be positive. And positive 1 times positive 1 is 1, so that works out as well. Very important. So now that we have factored it, we can find solutions by setting each factor equal to 0. So 2 cosine x plus 1 equals 0. And cosine x plus 1 equals 0. So subtracting 1 from both sides gives us 2 cosine x is equal to negative 1. Dividing both sides by 2 gives us cosine x is equal to negative 1/2. Subtracting 1 from both sides gives us cosine x is equal to negative 1. So now let's analyze these and get our solutions. Let's start with the negative 1/2. Forget the negative for a second. What angle, if you take the cosine of it, will give you 1/2? Cosine of what angle is 1/2? Now this is one of those things that you're supposed to memorize. See the 1/2 right here? The cosine of pi over 3 is 1/2, pi over 3. So that tells me that pi over 3 is going to be the reference angle that I should be looking at when I draw my diagram, which I love to do. So pi over 3, what does that look like? Well, this is pi, the top half. So I'm going to take this and I'm going to divide it 3 ways. So if I go like this, okay, now just looking at just the top half, I've divided it into 3 parts. So each one of these sections is pi over 3. So that means these are the 4 angles that will have a reference angle of pi over 3, because I've got pi over 3 here, pi over 3 here, pi over 3 here, and pi over 3 here. Okay, the reference angle is always against the x-axis. So all 4 of these have a reference angle of pi over 3. That means if I do the cosine of any of these 4 angles, I'm going to get some kind of 1/2. But 2 of them will be positive and 2 of them will be negative. Now remember, on a unit circle, every point x comma y is a cosine and a sine. Okay, so right now we're dealing with cosine, so we're talking about x values. So, you know how sines work on a coordinate plane. As we go, if we're talking about the x values, we're talking about moving to the right and moving to the left on the x-axis. So the positive ones are to the right, the negative ones are to the left. That means these 2 are the positive cosines, and these 2 over here to the left are the negative ones. Okay, so in this particular case, we want the cosine to be negative 1/2. So that means these are the 2 angles we actually want. Now, what are they? So notice the answer is not pi over 3, that's just the reference angle. So I've got 1 pi over 3, 2 pi over 3, so that's what this is. 3 pi over 3, 4 pi over 3, that's what this is. Alright, so my 2 solutions so far are 2 pi over 3 and 4 pi over 3. Okay, now what about the negative 1? Well, that's easy. I really hope this is going to turn to an eraser soon. Okay. So when I want to talk about positive 1 and negative 1, I'm just going to look at a nice simple unit circle with quadrantal angles, all right, the 90-degree ones. Okay, and again, cosine is the x value of any of these points. So where is the x value going to be negative 1? Okay, well, this would have an x value of positive 1 because I'm 1 to the right. This would have an x value of negative 1 because I'm 1 unit to the left. So this is the only angle that has a cosine of negative 1, and of course this is pi. So there you go, there's another one, x equals pi. So we have these three solutions to our original equation. All right, let's do one more problem. Problem number 9. This doesn't look like it's going to take a lot of space, but just in case, let me create a little bit more space. Oh no, my picture came down too. I'm just going to erase it. Okay, last problem for this video. Well, I just have the one function, so let's just go ahead and subtract 2 from both sides. So that's going to give me sine x is equal to 1. Wow, I guess I really am not going to need much space on this. Where is the sine function equal to 1? Well, sine is a y value on the unit circle. So where is the y value going to equal 1? Well, it's going to equal 1 up here. This has a y value of 1 because of the way it's up 1. And that is the angle that is pi over 2. So x must equal pi over 2. Okay, wow, that was the easiest problem yet. Sneaking in the easy ones. All right, well, that's going to do it for this video. More to come. Stay tuned.